let's do a video about the difference quotient. So again, hopefully the lighting here is all right, and hopefully the volume is all right. I should listen. Yeah, I'll listen to the videos after. So let's find the difference quotient for f of x equal to 3x squared minus 2x plus 7. So again, it's probably going to be in your best interest to memorize the difference quotient. It's f of x plus h minus f of x all over h. Some people use f of x plus delta x. Some people use f of a plus h. It's all the same stuff. And then I'm just going to write it out. So f of x plus h, everywhere in this function, I'm replacing x with x plus h. So I like to write it as 3. Everywhere I see an x, I like to write it parentheses. Minus f of x. So it's going to be all of this. And I do like to have a bracket or parentheses around this. Doesn't really matter what you choose to use. You can use a brace if you wanted to. And then in my parentheses, so f of x plus h is 3 times x plus h squared minus 2 times x plus h. And you can just remember what everything is. That's f of x plus h minus f of x. Super important that we distribute things carefully, because what should always happen in the difference quotient is the end goal is to make sure that that h cancels out. And the kind of sub goal that we have to get to before that is that everything on the numerator that does not have an h should end up canceling. But that's only going to work out correctly if you distribute things right. So I'm going to multiply x plus h squared. And you're going to see this enough that you're going to know that x plus h squared is going to always be x squared plus 2xh plus h squared. Just distribute the minus 2. So minus 2x minus 2h plus 7 minus 3x squared plus 2x minus 7, all divided by h. And I should have an equal sign here because this is equal to that. Alright, so now let's see, I can cancel a couple things. This minus 2x cancels with this positive 2x. This positive 7 cancels with this minus 7. But if I hadn't distributed the minus sign correctly over here, then they wouldn't have canceled out. So now I'm going to distribute 3 here and get 3x squared plus 6xh plus 3h squared minus 2h minus 3x squared all over h. I'm going to move this h, it's kind of close to my, there. And now I can see again on top the non-h things, 3x squared and minus 3x squared canceling out. Now you can either jump straight to the end, or you can take the additional step of factoring out an h from all the things on top that now have an h in them. So I've got h times 6x plus 3h minus 2 all over h, right? Because from here I pulled out an h, from here I pulled an h, so there was one left, from here I pulled out an h. These h's cancel, and then my final answer is 6x plus 3h minus 2. And this is leading us towards the definition of the derivative, where we're going to eventually say, okay, then all the h's go to 0 because we're going to let the distance between things get really small. Let's look at the other example I have on the other side. It's a little bit more complicated. Let's do the difference quotient for f of x equal to 1 over 2 minus 3x. Again, the beginning is always the same. It's always f of x plus h minus f of x over h. Always, always, always. So in this case, it's going to be, well, f of x plus h is 1 over 2 minus 3 times x plus h minus f of x is 1 over 2 minus 3x. And I picked a gross example over h. So for these ones, we have to get a common denominator, which is unfortunately just this gross thing times this gross thing. Now here's a nice trick. Instead of multiplying this by 2 minus 3x over 2 minus 3x, and this by 2 minus 3 times x plus h over 2 minus 3 times x plus h, you can actually just multiply the entire, let me do it right here, the entire top and bottom by this common denominator, which is going to be nasty. It's 2 minus 3 times x plus h times 2 minus 3x over 2 minus 3 times x plus h. 2 minus 3x. So here's the thing. We multiply at the top, it's going to be nice. We're going to distribute to each of these pieces. When you distribute this part to this part, The 2 minus 3 times x plus h cancels with the 2 minus 3 times x plus h, and we're left with a 2 minus 3x minus, when you multiply all of this, right, it's all of this multiplied to this, or distributed to that, the 1 over 2 minus 3x cancels with the 2 minus 3x, and we're left with just this piece here. All over. We don't multiply at the bottom. So whenever you're multiplying things out, like with a conjugate or with a common denominator, you want to multiply the parts out. They get simplified nicely. You don't want to multiply the parts that don't, because again, we're trying to cancel this h. It doesn't make sense to kind of distribute things out. So I'm going to get h times 2 minus 3 times x plus h times 2 minus 3x. Okay, now we're going to distribute on top. Or simplify on top. Again, we hope that all the not h things cancel out. So hopefully I have enough room here. I got 2 minus 3x minus 2 minus a minus is plus 3 times x plus h. I'm going to distribute 3 as well. Plus 3x plus 3h. Right, because it would have been a plus 3 times the x plus h, and then the 3 distributes to each of them. All over the same denominator. I would love to not write it out, but I'm going to write it out. Let's go ahead and, no, let's just leave it. So there's the whole thing. And then on top, we see that all the non-h terms cancel. 2 and negative 2. Negative 3x and positive 3x. And then I'm left with just a 3h over h times all this. So I can see that that h there and that h there will cancel out as well, right? It's division, where you can factor out the h, but since there's only one term, it's kind of weird to factor it out. And just get 3 over all the things that aren't there. So I've got, all the things besides the h there. Again, we're only trying to cancel out this first h that was in the denominator. It's okay that there's some other h left in the denominator. I would not multiply this out. I would leave it like that. Now again, the idea here is that when we move on to doing the limit definition of the derivative, we're going to let the remaining h's go to 0, which is why I have to simplify this, because if h goes to 0 right now, you get 0 over 0, which is indeterminate. But now that we've canceled an h, if we let the rest of the h's go to 0, that goes away. And then this simplifies nicely. This becomes 2 minus 3x times 2 minus 3x, which says 2 minus 3x squared at the bottom. So there is a reason to not multiply it out, other than laziness. All right, good stuff. Watch the videos.